Solar is a legitimate email that it's a Unix box locked up in a private office or lab at school. I have remote access to it. No one else does. And so I sometimes, for efficiency reasons, send it from it's a department computer. I send it from our department computer files that you'll need. Some of them I ready to yesterday, so that's Solar. Okay, for those again, I'm sorry I have to repeat it because we have 3 or 4 registrants since last night. Okay, all of your emails. I'm sorry. All of the Y button, it's a little stuck. All of your emails should come from QMail, but sent preferably to the class email. It's not a class email in the sense that anyone else has access to it. It's a private email that I have, no one else has, which I use for this class. But I call it the class email. I know what better to call it, and it's the following email. So please, regardless of what class you're registered for, please send all emails to the following. I need to make the my QMail, which is R. Goldberg here. This one over here is my QMail on line 3. I need to make that available for administrative emails. So if you could, but it has to come from QMail. If you don't send it from your QMail, I won't respond, or maybe I'll write reply, please send it from your QMail. But let's not delay the responses. Just send it from your QMail. But for efficiency and whatever reasons, send it to the class email. Okay. But when I send something, it will come, when I send you an email, it will come from my QMail above. I don't know how it appears. There are slight variations in the email and the mailing system, aliases, which are this email. For example, Robert.Goldberg, Robert_Goldberg. At one time they did staff/Goldberg/Robert@CUNY.edu because there were some of these legacy aliases. But the point is, if it's something Goldberg at CUNY.edu, then you could, high probability it's me. Anyway, I will send from your QMail. The only possible exception is if if the system's down, then I would send it from 381. Or if I'm replying to what you sent, it's sometimes faster just to reply on 381 since you sent it there. All right, anyway, I don't want to waste too much time on that. Let me just think. There was one other thing. Let me just think. No, I guess not. All right, again, for those who walked in, I will be maintaining, not now, but starting this afternoon, I will be maintaining a list of all files that I've sent to you, and I will, so that we can constantly look at to see if I sent out today's notes. For those who walked in, every day I type these notes up for you, and I send them to you. Yes, now I remember. Another point I have to say. So I send you these notes. I advise you to type your own notes. I always think that that's a good pedagogical way of learning material, but as a backup plan, I always send you anything I typed. You have to ask. I send it to everybody. Okay, everyone registered, that is. Okay, the key thing I want to say yesterday was I was doing a perusal of those who submitted the keywords from yesterday's lecture. A reminder that every lecture day there is a keywords assignment, and it's due by midnight. Okay, and you maintain the same file. I believe I sent you the file. I certainly hope I did. I believe I did. But again, I will double check all files I sent you. I believe I did. And you keep maintaining the same file, growing it throughout the semester, and you keep uploading the same file but the updated version. Okay. When I looked at what people were doing, I noticed that instead of being judgmental, the bottom line is you left out a number of important key terms. Now, so I think that I'm thinking today how to present to you the level of quality control that I would like you to employ when you're doing keywords. So I came up with the following. For the purposes of this class, I think it should be for the purposes of all your classes, but I'm only concerned for today for our class. For the purposes of this class, in terms of what is considered a key term, okay, employ the following heuristic. I'm going to break this up into two pieces because the first one I truly believe applies to every one of your classes. The second one is somewhat unique to genetic algorithms. Okay. Any, again, term, phrase, or name that would be introduced in any, not just ours, in any computer science, math, mathematics, or physics class is a key term. B, let me copy it because it's basically the same, but the slight difference. Unique to our class is the fact that we incorporate natural sciences, so I got to do the same, but instead say biology, genetics, or chemistry. And there's the Y again. I have a sticky Y. So if in the notes you see a missing Y, it's my keyboard. Please tell me, I'll fix it, but I'll try to clean it up. All right, so that is a key term. That is the level. So for example, yesterday was only the first day, but I was surprised that some people did not put down infinite loop, which was an important concept and will be an important concept. Some people did not put down a Turing machine, effective computation, which, by the way, minimally, if a term, phrase, or name is bolded in the notes, it is a key term. I was very surprised. I bolded effective computation. A number of you didn't have it. So please take it seriously. The first half of the final is definitions. So, I'm hoping you're going to be a little more serious about that. Anyway, so please take that. Okay, so that's all I wanted to say. Okay, if you have questions, please ask. The way you ask is simply type. At any point, I hear a bing, a ding. For some reason, the lower hand, raise a hand doesn't really work. I don't know why. It really just doesn't. I think there's a very delayed reaction when I get to see it. So I don't advise using lower hand, raising hand, etc. But do text. Yeah, I know. Oh, okay. You mean now? Right now, there's an audio lag. Please reply. Okay. All right. So give me a second. Okay. Give me 1 second. I'm going to release memory from my machine so that way it'll be more dedicated bandwidth. Give me a second. I'll try to fix that to the best that I can fix that. Beyond that, it is it's actually what you call it. It could be the server. So give me a second. Okay, I released a ton of memory from my system, so that way you have... anyway, bottom line, is it better now? Is it better now? Good. All right, so that's it. It has to do with bandwidth. Okay, great. Thank you all. Thank you. We're good. So it happens to do with bandwidth, and at times, well, one of two reasons. Bandwidth could be on my end. It could be in my local network where I'm giving the class from. Sometimes it's the Blackboard system, unfortunately, in which case that's nothing I have control over. But at times, by me releasing my processes that I run, it frees memory and speeds things up. Anyway, I'm just telling you. So that's why we did it. Good. All right. Okay. Waleed asked the following. Okay, for infinite loop, for example, in terms of a term Waleed's asking, okay, Waleed asks, if we define the procedure and utilize infinite loop in that definition, is that okay? No, excellent point, Waleed, no. Each term deserves a separate, it's the word process and the word infinite loop is supposed to have separate definitions. Excellent point, Waleed. I do understand that you're correct that infinite loop was for the purpose of process, so I know exactly what your question is about. It's a good question, but please don't. Keep each separate. Okay, good. Thank you, Waleed. And Shu, who asked the following. The key term definition, how many sentences should we put? I leave that up to you. I just want you to be honest to yourself. That's all I'm asking. Okay? You know, don't dump web pages. I also know how to copy and paste. I'm hoping you can put in your own terminology, because then I think it'll be more integrated into your mind's knowledge. But I'm leaving that up to you. As a rule of thumb, between 1 to 3 sentences, but I'm leaving it up to you. Okay, that's shuhua. Now, oh yes, some of them may only have one, some are a paragraph. If you have a paragraph, then I think you're writing an essay. The Webster definition of a definition is that succinct, which means that it's straight to the point. It should not be a paragraph. I mean, there's a lot to say. You know, Al Turing, if you wrote it up, there's a lot to say about him. But that's an essay. The point is, the reason the term was brought up in the lecture only be 1 to 3 sentences. Okay? All right, so I think that answered that. Those were some good questions, and thank you. Unless, Shuhu, do you have a follow-up, or does that answer your question? Okay, I think that answers the question. Okay, good. Great. Excellent. So let's continue. All right, so the quote-unquote homework I gave you last night. Again, as if you looked at the syllabus, you all have it. Again, I'm going to post all the files I've sent. Just in case you don't have something, email me. As soon as I post it, I'm going to email the class to have a continuous list of all the files and important documents that are related to the course that I'm going to be posting. So you'll have a list, and you'll know what you should have. Anyway, let me just think quickly. Yes. So I pointed out in the syllabus where it says various homeworks, and there's no points awarded to that, because it's not graded, and I'm not asking you to submit. I'm just asking you to do it, though, because it'll help your learning process. Very often these homeworks are supposed to be for you to have time to think about things overnight, because we're going to go answer them and incorporate them in the very next day's lecture. Okay, so what I asked you, if you could have, I think it'll be a little more interesting if you had some time trying to go through the 8 related fields that I mentioned to you last time. And let me just copy them over here quickly right now. Where do I have them here? Yeah, give me a second. Okay, good. Where is this? Here they are, July 2nd. And let me sort in by alphabetical order, or not, but anyway, sort. Okay, good. And then we just have to delete one. That's over here, that word. Okay, so I presented to you yesterday a quote-unquote homework, but we're going to do them now. We'll okay, so let's insert here and say, well, so I'm going to go over them in whatever order. I don't think I'm going to follow this order, but okay. Anyway, related fields. All right, so a point I mentioned yesterday, well, we'll bold the fields later when we do them. A point I mentioned to you, very important point, but not something we're going to dwell on too much this semester, is the name genetic algorithms. Right, the name of the course is genetic algorithms, but that name sometimes implies to the average person the wrong direction. The name genetic algorithms at times implies to the average person the wrong perspective, slash direction of the material. Okay, what do we mean? So there are 2 aspects, there are really 2 fields that are mentioned in genetic algorithms. One is genetic, which is part of the natural sciences, like genetics and biology, but algorithms clearly is pretty much owned today by the computer science field. Yeah, I mean, different fields have algorithms, and mathematics claims some degree of that. They actually have the term programming, but they really mean system of equations in their terminology, programming. But they do entertain, as it has mathematical logic in it, clearly. So maybe mathematics could stake a claim to the word algorithms, but basically genetics is part of natural sciences, a branch of biological sciences, and algorithms is pretty much what you call computer science. Right. So the question is, who is modifying whom? So people think that genetic algorithms are algorithms to help you understand genetics, but really it's the opposite direction. It means, how can we be inspired by genetic processes to create newer versions, innovative versions of searching and optimization algorithms, right? So it's the being in the correct perspective. Again, in yesterday's notes, I talked about this in a little more detail, but just in summary, as a branch, a jump-off point for the related fields, the correct perspective of this name is being inspired by genetics, and it's a little broader than genetics, biological sciences, to create, to construct, to create, to create new / innovative approaches to searching and optimization. Indenting is not purposeful except to, let me explain that. It's only there to make things hopefully easier to read, sort of in like, not like outline form, but when I have a finishing up of a sentence, I usually indent it. It just makes things, I think, hopefully easier to access in the notes. That's why I do it. So don't read too much in my indenting purposes, but I'm hoping that'll be easier for you to find things in the notes. Okay, anyway. All right. Well, so the opposite direction would be more of the opposite direction, which is not us. The opposite direction, where computer science, AIDS, biological sciences, AIDS, biological sciences, generally fall under two, probably more by now, but classically fall under two fields, at least classically did. I'm sure the more modern fields. Anyway, they're called, one of them is bioinformatics, which is using databases to figure out patterns of genetic sequences, DNA, RNA sequences, some informatics, and computational biology, which is a little bit more mathematical, but it uses mathematics and computer science modeling to understand different types of, as I say, biological growth, circulation of blood circulation throughout the whatever, etc. Okay, so that's the opposite direction of which we are not. But that's what when you talk to people and you throw out the main genetic algorithms, and you can be honest to yourselves, it's possible when you saw the term and you registered, you may have thought that as well. But when you did some research on the web, and hopefully you looked it up to see what it's about, you realize that it's not. It's the line 25, 26 perspective, not the line 27 perspective. Anyway, so what I would like to do is, there are a lot of related fields to line 25 and 26, namely the ones, again, what I present above, lines 14 to 22 on your screen. All right, so let's talk a little bit. We're only going to summarize these fields. We're not going to spend time too much. Only two of these are we really going to spend time this semester. Genetic algorithms, obviously, but the second one is genetic programming, and we're going to compare and contrast their approaches. But the genetic algorithms and genetic programming, despite a philosophical difference and data structure difference that you'll see, actually is trying to do something very. All right, so let's just think. Genetic algorithms. So, well, okay, they were obviously going to spend the whole semester talking about it, but let me just think the right way to tell you. All right, okay, genetic algorithms, again, is a genetic or biological science-inspired approach. Biological sciences, specifically genetics, but it has it broader nowadays. A point we'll mention a different class is a biological science, mainly genetics. Okay, let's say mainly genetics. Mainly genetics approach or inspired approach to again searching and optimization. We'll talk more about searching and optimization today, but fine. So, it differentiates itself. The genetic algorithm, GA, again, that's a term, a a standard acronym that everyone uses. GA will be genetic algorithms, and although we don't spend as much time, but GP will be genetic programming. Anyway, GA is searching for solutions. That may sound trivial to you, right? But it's not. It's actually very important. It's searching for solutions. Now, Goldberg's book talks about the optimization, this and that. We'll talk more about that, but generally, philosophically, GA is searching for solutions and employs arrays, typically, most typically, if not always. I'm always afraid to say always because there's so many varieties and variations that exist in the literature. I don't want you to come back to me and say, well, so-and-so in 2019 uses something else. But employs, at least classically, okay, so that term again, classically or / most typically, uses arrays and employs arrays. And again, because of the variety, I have to put in this disclaimer, which is that, again, classically one-dimensional arrays. There are those who, and we'll mention that briefly, we don't spend too much time on it, but we will mention multi-dimensional later in the semester. But classically it's one-dimensional, to store suggested solutions. All right, so in a nutshell, GA is searching for solutions and employs arrays to store the suggested solutions that you're entertaining, that you're trying to figure out, are they good enough? Now, what I haven't, I guess we should, GA updates itself to these solutions, i.e. the suggested solutions. And here's the inspiration of biological scientists, really genetics mainly, updates itself based genetic processes. Okay. So that's a nutshell. Obviously, again, we're going to spend a semester on this, so you'll get to understand what this means. But in a nutshell, that's the story. The genetic processes. Okay, let's just say what they are. Already, we'll put a colon. A selection of mates, and then crossover. Sorry, it's spelled crossover and mutation of genes. All right, so now this is gonna already. I sort of, in other words, I won't say well, technically contradicted myself, but it's not really the case. This is the way they talk, and that's something you're gonna have to learn. Although biological sciences and genetic researchers are very careful about the terminology, GA took both the genetics and the biology at the same time, and they conflated a number of terms. So I'll mention this a different time, but the point is gene, chromosome, individual, organism, unfortunately in GA become the same thing. So that's why the selection of mates, which is at the individual and organism level, it can be in the same breath as crossover and mutation of the DNA, which is at the gene level, right? Amino acid level. And yet, I introduced that by saying that that's all genetic processes. The selection of mates is a biological situation. It's not necessarily a genetics situation. The human being, the organism, selects who to mate with to have subsequent generations and to populate the environment, right? So it's. I guess I should. All right. So I guess I'll have to be honest to what I have to say, biological processes. But it's really not. It's only because they did this that I have to say that. GA, and that's why the name is genetic algorithms, views itself as if it's always genetics. The truth is there are some biological processes that are thrown in there too. Well, you're throwing out a term. And that is a philosophical term. That we're going to have to deal with that, but we're not going to spend too much time. The assumption here, okay, the way, let me make short and sweet, and then when we get to it, we'll elaborate. The way GA uses mutation is not natural selection. So it isn't, despite the fact that, well, let me not despite the fact. Good question, Walid. But the answer is the way GA uses it, it's not. So, but we will get to those terms, at least for definitions. We're not going to spend too much time on it because, as you see, it's not exactly as relevant to the actual genetic algorithm. But Waleed, your point you're bringing out a very important point, which is that the researchers, and I alluded to this just now, but you're bringing out another facet, which is that the researchers of GA aren't really too consistent and too exact to employ the science terminology. They were inspired, but not necessarily followed those approaches. It's unfortunate because you have this dialectic, this tension in the GA community namely, to what extent should you be exact in following the genetic and biology processes. But as I said here, even in the terminology, you see that there's an acceptance of, as I say, conflating levels. No respectable scientist is going to confuse the chromosome level, the individual level, the organism level, the population level. They're not going to confuse them. But you're going to see in the terminology, a number of these levels are going to be interchangeable when we discuss them. Not because I'm being sloppy, it's just the field at large. They got inspired, did what they wanted to do, and they're happy with it. And beyond that, they weren't so exact. So I will constantly point out to you where those differences are. Okay, so it's an interesting point which we will discuss, but we'll discuss that a different day. So thank you for your comment, Waleed. All right, now, where are we up to? Yes, that's GA. So again, GA is searching solutions as opposed to genetic programming, which I'll mention in a second, and employs arrays to store the suggested solutions. Okay, now genetic programming. GP also is, let's copy this from the above. There's a lot of similarity here. It's also a biological science, et cetera, right? And also here, the GA updates itself in the same concept. Well, not saying the same philosophical concept, using the same, basing itself on the same processes, the same genetic/biological processes. The difference, which is very different, is the line in between. So one more time, GA is searching for solutions, GP isn't. GP is providing algorithms. In essence, it's searching not for solutions, for code. The algorithm is going to be represented by code, most typically Lisp in most literature. Most typically the Lisp programming language, most typically represented by the Lisp programming language. Now, philosophically this is correct. I'll have to elaborate in a second. Okay, give me a second here. Where are we up to? So now right, correct. And employs not arrays, employs trees and graphs to store the suggested algorithm/code. Okay? So that's a very big difference philosophically. If we have time, I could show you that it's a little less different than you think. But certainly the way that's the case. Now, the reason why I put and graphs, it could be and graphs, although it's generally what you call it. It's generally the it's generally trees. In most researchers, it's trees and not graphs. Although it could. Okay, the reason why it should be graphs is the following. Okay, historically, there's a precedent. And my Y in the keyboard. Historically, there is a precedent for representing logic using graphs. Representing logic using graphs. Okay, let's see if you get it. Let's see if anyone knows what I'm referring to. Again, historically, so we're not dealing with something necessarily in the last 20 years. I'm referring to something 50 years ago. So let's see if you know your history of computing. Do you know what I'm referring to in line 37? Does anyone know what I'm referring to in line 37?